So we need to be able to draw Lewis structures for molecular compounds and for polyatomic ions. So here's a set of guidelines for that. And there are different ways to go about arriving at the correct Lewis structure. And so if you have a different way that works for you, that's fine. But this is how I'm going to present it. So start out by figuring out the correct skeletal structure. And what we mean there is, how are the atoms connected to each other? Kind of like a skeleton. Like, how are the bones put together? And then we'll kind of flesh it out with the electrons later. Things to consider here. Hydrogen atoms are always terminal. Terminal means it's on the outside. It's just got a single bond with something. You'll never get a hydrogen in the middle with lots of things bonded to it, because hydrogens can only make one bond. If you're not sure which ones to put in the middle or on the outside, a good guideline is electronegative atom. The more electronegative one probably goes in the terminal position. So after you figure that out, and sometimes you have to go back and change it later, then you need to figure out how many valence electrons do I have for the whole structure. So you look, I've got 2 hydrogens. Well, each of them has 1 valence electron. And I've got a carbon that's got 4, and you add them all up. If you have an ion, then you have to take that into account. If it's a -1 ion, that means it's got 1 extra electron. If it's a +2 ion, that means you need to subtract or take away, remove 2 electrons. So then you put a single bond between each connected atom, and then you start handing out electrons. And you're trying to get a duet for hydrogen and octets for everybody else. Sometimes you run out. There's not enough to go around, and so then atoms have to share more. And so then you make double or triple bonds. So let's practice this. Write the Lewis structure for carbon monoxide. So writing the skeleton structure for this one's pretty easy because there's only 2 atoms. They must be connected to each other, right? There's no other way to do it. So the next thing is, how many valence electrons in the whole molecule? Carbon has 4. Oxygen has 6, right? That's a total of 10. So that single bond, remember, is 2 electrons. Put the dots there if it helps. So now I'm going to count to 10 by 2s, right? I've got 2, 4, 6, 8, 10. Ran out of electrons. Does everybody have an octet? Nope. Nobody has an octet. We need to do more sharing. So I'm going to take one of these lone pairs, and I'm going to make it a bonding pair. So I'm just going to erase that one and put it in here. Now it's a bonding pair. And we see, what do we have? Well, the oxygen has 2, 4, 6, 8. The carbon only has 2, 4, 6. So carbon's not happy yet. Oxygen is good. Oxygen has 8. So oxygen can afford to share with carbon, and carbon doesn't have enough. So we're going to take a lone pair from the carbon now and share it. Lone pair from the oxygen and share it with the carbon. Now the carbon has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. Everybody's happy. Drawing Lewis structures is nice because you can make all the atoms happy. That looks a little ugly, right? So let's just draw it again more neatly now that we know what it's going to look like. So here's the carbon, and there's going to be a triple bond, so 3 lines with the oxygen, and then each of these is going to have a lone pair. You can put the lone pairs on the top or the bottom, it doesn't matter. I just like the way that one looks. Any questions? Let's do H2CO. Well, the hydrogens are going to have to be on the outside, right? So let's see, we'll put the carbon and the oxygen next to each other, And then I'm going to put the hydrogens on there. And this is where it can help to think about, well, how many bonds does carbon like to make? How do you know that? You look at its Lewis structure. It has 4 valence electrons. They're all unpaired. Oxygen, 6 valence electrons, 2 unpaired. So the oxygen, we can anticipate, is going to want to form 2 bonds. And the carbon's going to want to form 4 bonds. And so if we kind of keep that in mind, that can help us avoid making the wrong structure. And we're going to learn something called formal charges in a minute that's a little more rigorous. So I've got these 2 hydrogens I need to stick on there. Carbon would like 4 bonds, oxygen would like 2. Where do you think I should put the hydrogens? Probably on the carbon, right? So I'll put the hydrogens on the carbon, and we'll see how that works out. Because now that carbon's got 3 bonds and the oxygen has 1 bond, and they're like both just 1 away from what they really want. Then we have to add up electrons. I've got 2 hydrogens, they each have 1 electron. 1 carbon has 4 electrons, 1 oxygen has 6 electrons, so I believe that's 12. So I've already got 2, 4, 6, 8, 10, 12. I didn't quite have enough. The carbon, that's not an oxygen. The carbon here has an octet, right? The oxygen doesn't. Now, if you started on the oxygen, you might end up with the carbon not having an octet. What you want to do here, when we've run out of electrons, we need to make a double bond. We're going to take a lone pair from the atom that has more. Here, this one has an octet, that one doesn't. If I take a pair from here and move it in there, then the carbon's going to have too many, and I'm going to have to take these and move them over there, and just a lot of shuffling. So I'm going to take a lone pair from the carbon and bring it up here and make it a bonding pair. So now the carbon has 2, 4, 6, 8, and the oxygen has 2, 4, 6, 8, and hydrogen's always happy if it's got a single bond. And then we could draw that more neatly. Carbon, hydrogen, hydrogen, double bond with the oxygen. And the oxygen has 2 lone pairs. So this is the nice, neat final answer, and this is the nice, neat final answer. Any questions? Whiteboards are really good for doing Lewis structures, and the iPad is too, because it's just really easy to erase things and write them somewhere else. Pen, not so good. Pen and paper. Pencil is okay. Okay, let's do an ion. This is hypochlorite ion. Well, there's only 2 atoms, so then we don't have to struggle with how do we put them together. They must be connected to each other. Next thing is count up the valence electrons. How many valence electrons for chlorine? 7. And how many for oxygen? 6. And the -1, I add an electron. So I've got 14 electrons here. So in that bond, I have 2, 4, 6, 8, 10, 12, 14. It does not matter exactly how you start distributing those. I find it works well to just to kind of sort of spread them around instead of starting at one end and going to the other, but we'll end up at the same place in the end. So look at that. We had enough electrons. We didn't have to make any multiple bonds. This is an ion that only has a single bond. It's not complete, though. We need to put brackets and indicate the charge. Because there's another thing that's ClO without a charge, chlorine monoxide, that's a molecular compound, and that only has 13 electrons. not 14. So we got to put the charge on there so people don't think we're drawing the wrong thing. Just a word about mastering chemistry. You'll have to do some Lewis structures of mastering chemistry. Mastering chemistry can't do the brackets. The program just doesn't do brackets. So you do still have to put the charges on there, but it won't do the brackets. So don't text me and ask me, how do I get the brackets of my Lewis structures? You don't. They haven't figured out how to do that yet.